All right, guys. Looks like the stream is live. Okay. Well, everybody, welcome to the latest Ultralytics Live Session. So this is live session number 17. This is a series that we do to grab the community and engage with everybody, let them know the latest and the greatest in the YOLO space, what's going on in computer vision, and also to give you guys a sneak peek at some of the cool stuff that we're engaging in with some of the other companies out there. So in this case, we've got Sony with us, which is really exciting. So we've got two people from the Sony team here. We've got Tang, who's in business development, and then we've got Amir, Servi, product manager. So they're both working on exciting hardware updates that they're going to tell us about. And here on the Ultralytics side, we've got Lakshantha. He's joining us from Canada. And I'm Glenn. I'm the founder and the CEO here at Ultralytics. And I've also spent a lot of time doing a little bit of YOLO. And I'm joining us from Shenzhen, China. So we're here with the Ultralytics team setting up a little bit of a hub. We're at the WeWork in Nanshan. So this is our second time in the country. I know there's a passionate following here for computer vision and AI, and we are working with the community to try and engage and also to let everybody know what we're doing. So without further ado, Wei, why don't you take it away? Give us a bit of introduction to Sony. So I think everybody knows Sony. I think from my days, from the Walkmans initially, and then the PlayStations. But of course, Sony's got a long history in cameras. And it looks like in this case, the camera history and the computer vision space are intersecting a bit these days. So.
Sure. So, thank you, Glenn, for the introduction. So maybe Amir, you can share our screen as like some like
yeah, 1 second.
Yeah, in the background. Yeah. So hi everyone. So this is Wei. I'm actually joining this webinar from Singapore. So I'm in the same time zone with Glenn today. So here. Yeah.
We're all spread around the world.
Yeah,
I
we're
bet our
all
users are all over the place
actually.
too.
Yeah. So today, so this webinar is kind of like continually to our partnership, which we released previously to the public. We've been working with the Ultralytics team for quite a long time, but starting from this open source collaboration, we gradually deliver things to the public, starting from which we're gonna share today. So before that, maybe everyone knows Sony. It's a big name, right? It's everywhere, maybe around you. So actually, our team, we are from the Sony Semiconductor Solutions. As you can see here, the broad Sony group, it covers from like gaming, music, movie, like everything, even finance. A lot of like banks in Japan, actually. Maybe someone, they are not familiar with this part, but actually Sony is like kind of like in many different industries. So our company, our team belong to the Sony Semiconductor Solution. We are specifically focusing on developing the cutting-edge image sensors that enhance everyday life. So maybe you've already seen a lot of like our sensors on your smartphone or like automotive vehicles. It's everywhere. So the fact is that actually the Sony Semiconductor Solutions, it actually holds the largest share of the global image sensor market. So we shipped out over maybe 1.2 billion sensors every year. So I think half of the mobile phone, yeah. So everyone is using a smartphone, right? Actually, half of them it's equipped with our sensor in your cameras. So we are kind of really quite.
So even if we don't have a Sony smartphone, chances are we still have like a Sony CMOS sensor or a camera sensor.
Yeah, exactly. Yeah, so that's what we do from the beginning of this business division. So we did a lot of like traditional these image sensors. So we've been doing like a lot of these things to commitment to the innovations and quality that's also position us as a leader in this industry. So Sony itself has already democratized this recreational photography. So now we would like to do the same thing for the vision AI, which is quite new to most of people because we're not in that AI so much as far as you may know. So we still start from which we are experts in from the image sensor itself. So we are kind of like reshaping our role in this image sensor in this AI era from like our traditional imaging, just try to like improve the quality of the pictures you took for like your daily life. Now to the sensing, we want to see and understand the scenarios beyond like the surface, like more into like sensing the difference like from its surface. So from this big like change of our role and our commitment of this new AI era, so we actually have created this new sensor, which is in the next slide. Maybe Amir, you can share our sensor. Yeah, so this is the intelligent vision sensor we created, which we call it IMX500. It's actually the world's first intelligent vision sensor that's equipped with AI processing capabilities on chip, just on the chip, on real time. So as you can see, it's actually, yeah.
So wait, this is
Yes.
a really cool spot for me because traditionally there's a big gap between the sensor where the data is collected and where it travels to before it's processed. So that involves like a separation here. And what you guys have done is you've taken that AI processing, you've taken those tops, you put them right behind the vision sensor into a single device. And so that means that
exactly.
if you plug this into something else, then like a Raspberry Pi, then the Raspberry Pi is not like overly burdened with processing that imagery because it's already done on the sensor. So that's super cool. And that's a big differentiator here, I think.
Yeah, exactly. So you can see a lot of potentials by combining, or like you can utilizing these on-chip AI processing capabilities to do a lot of things on chip, saving a lot of resource, as you mentioned. Like traditionally, we do it like another board, another like MCU, whatever. Now you actually can balance this resource, and also the good thing of like on-chip AI processing is that it has no like latency, right? It's must be real time, high speed. Exactly, we mean real time, right? And also we actually have some like metadata outputs on this AI logic layer that help you to like like in most of case we are concerned about privacy, especially like human related analysis. So what we call it metadata is that we don't do like the traditionally on the left, as you can see, the sensors, they capture everything from the device. However, in our sensor, and when we only deal with AI processing, we only deal with the metadata on the right-hand side. So you cannot see any personal or privacy information on it. So it's not only help solving this privacy related issue, also it can largely save the cost of this high like resolution image size of like to the crowd, right?
Absolutely. So you're dealing with a lot less bandwidth. There's a mode that you can set this where only the detections are being output, which saves tremendously in terms of cost. So if you were to scale to say thousands of cameras, then this is something where you're only streaming metadata instead of imagery, which could really, really help you scale without scaling the compute.
Yeah, exactly. That's what we want to do because like nowadays, the IoT devices, cameras is everywhere, right? Like people just take it for granted, they use for it. But actually, if we really look at the huge consumption of this data from the edge to the cloud, it's massive. Yeah, I don't know how this is gonna be sustainable if we do it continuously like that with the more increasing usage of AI processing like the tasks. So I believe to do the real edge AI specifically for some use cases, it's necessary and compulsory.
This is sort of like the ultimate definition of edge AI, right? Because the imagery it's not even going to a processor at the edge. It's simply being processed directly on a capture device.
Yeah, exactly.
Yeah, and also I think when it comes to IMX platform, so from what I have seen in the past, so when you guys release like different camera sensors, it's always named IMX. Am I right? Is it always IMX? I'm just curious about it.
Yeah, that's the naming rule actually. So
right.
Yes.
Got it. Because
I think there is a rebranding in the background, I think, but we will see that. But yes, it's IMX for most of the sensors.
Yeah,
Most of
most
the
Sony sensors. Yeah, and
Cool.
actually the digits it actually has some representative meaning, normally
Mhm.
representing like resolution, some like orders of this sensor in the production line, things like that. Yeah, but that's the way we call it. It's more like internally we track projects and share these kind of things with the supply chain.
nice.
Yeah.
So
Okay,
I
so
suppose this
let's
Lakshantha was asking. So this isn't the first IMX camera, but
Yes.
it's the first with
Yeah.
okay. So, and then Amir, you were saying that the branding is going to kind of clarify a little bit going forward for new devices. Okay, yeah,
Yeah.
yeah. Because I have heard of IMX before, not the 500, but the 500 is the first series with the onboard processing.
Exactly.
Yeah, exactly.
Because
So
even for me, I have used the Raspberry Pi cameras in the past, where it's based on IMX 219, IMX 477, right? This kind of IMX chips. The Raspberry
yeah, that's
Pi camera
different.
1,
That's
camera 2, and the
different.
camera 3, right? The official camera.
Yeah.
So that is why I also heard this name when I was using the Raspberry Pi cameras in the past.
Nice.
Yeah.
Yeah.
You really pay very detailed attention to these things. So yeah, it's Sony sensors. Yeah, the naming, the numbers
Cool.
representing different meanings actually. Yeah, so as you can see here, this IMX500 series is kind of very new. We are kind of like the starting one, right? It's 500. So
Okay.
it's representing for this intelligent vision sensor, the naming. So as you can see here, the sensor itself, it's not like useful enough, right? So we already equipped into these hardwares, both in-house and co-work with third party, to be IMX500 enabled hardware. So for AITRIOS. So here AITRIOS is more like our overall platform name. So we actually build up not only the hardware ecosystem, which we have a lineup of these camera devices equipped with the Sony IMX500 sensors. Also, we build up this Edge AI platform, we also call it AITRIOS, to provide you the basic tools to like develop, deploy, or manage even the device, the AI, the things. So you can easily to implement these Edge AI solutions by our device and by our platform.
Okay.
Maybe worth saying that this is mainly for the B2B world, for the commercial world, and we will see in a few minutes how can the community enjoy this technology. So yeah.
Wei, I've got a stupid question here. Is AITRIOS an acquisition of Sony, or how did how did the group come around? Could you tell us a little bit about the history?
Okay, so AITRIOS is more like this overall platform, or let's see this overall team. This naming, it's not like a separate like division or like like
Okay.
sister company, whatever. So no, that's actually not. So so this AITRIOS here is actually the name is actually meaning AI plus 3S. So Tro is 3, right? So
Oh,
it's
trio,
AI
trio. Yeah,
plus
yeah, trio.
Tro
Yeah.
S. Yeah. So
Oh,
the
okay.
interesting meaning of Tro S is like it can represent a lot of S. For instance, our company name is Sony Semiconductor Solutions. It's 3S, right? So
Yeah.
also we believe this 3S can also representative for what we want to deliver, like the social value, sustainability, and society. That's something we
I like
also
that.
think about
Yeah.
in the scope of the solution. So the naming of AITRIOS is actually very, very meaningful. So yeah, if you look at it carefully, it's connect with this team from this SSS, Sony Semiconductor Solution, and also connect with our keywords of this AI solution, and also covers our vision to deliver to the society, to the social life, and eventually sustainability by leveraging these resources to the edge.
Yeah, low power compute.
Yeah.
Oh, very cool.
But
Is
maybe
it also somewhat reflecting with the 5S in Japan? Because I know in the Japanese culture there is
There's a
5S.
5S.
Yes.
Is that better than
Yeah.
3S's?
No, it's just different. I think it's just
Okay.
different.
Just different.
Yeah. Yeah.
That's a lot of S's. I'm not sure if I could remember all this.
Yeah.
Three's pretty good.
Yeah.
Okay. All right, Noah, sorry for interrupting. Go ahead,
Yeah,
Wei.
so as Amir mentioned, like when people hear solution platform, they connect with the idea of like very commercial, very like business solutions, right? So so actually our platform, as we show in this next slide, is that we build up this platform as a basic service, including our device, the basic capability of device management, and basic tools of AI module distribution, like training, management. But it's not like solely developed by us. We also partnership with a lot of like leading players like Ultralytics as our future potential integrated player into the platform to provide you like very good like AI training services. And we also work very closely with partner ecosystem because we know a lot of like solution people want to solve very like application level use case, not only AI module level. So we do have these kind of partners like system integrators who works widely in different industries. So we don't like specifically target a vertical. We are providing a basic platform capability together with our hardware capability. And by closely working with this partner ecosystem, so we can actually contribute to a wide like different verticals, like to solve more application level use cases. Yeah.
That's good to hear, Wei, because at Ultralytics, we've also not specialized in any specific verticals. Like we do see some where YOLO is pretty popular, like manufacturing, but since we're small and we lack resources and most importantly, expertise in those verticals, we focused on really the core models, the technology itself, and serving the community. So it's really interesting to see a large enterprise also like Sony taking the same stance.
Yeah, so we actually put two real commercialized use case here to give people an idea what we do exactly. So just examples. So actually you can track like all these details online. It's already public, commercialized. For instance, in Japan, we have like these two projects which is already being commercialized. One is that we work with 7-Eleven, like very big giant of this convenience store chain. Not only in Japan, maybe also in US, I believe in China as well, everywhere, right? So the 7-Eleven Japan, they actually utilize our solution to do the digital signage at starting from their 500 stores to do this in-store advertisement analysis. So simply, they actually put the solution and our camera into the TV screen of the cashier. So in Japan, when you do checkout in the cashier, you actually have some like TV screens. They place different advertisements. So by our solution, you can check real time like people's attention to look at the advertisements, like how long they stay to look at indicates how interested they are to that kind of like contents, right? And matching with like this kind of face attributes and like different people at different like times, we can figure out what's best like ROI for different advertisement to be placed. So this is what they do actually in many of their stores already. So this is one interesting use case. So
Essentially,
another use case, yeah.
Essentially, they're doing Google Analytics on brick and mortar.
yeah, exactly. Yeah, yeah, that's the TLDR version. This is really amazing. So, because we're all used to Google Analytics, where you can see, or even just Google advertisements, where I suppose you could select like who you want to show ads to, and this is sort of the real life version of that. But it also allows you to do A/B testing. So if you put up two ads, you can see how much people look at them. Yeah, it's really incredible. It's just like you said, Amir, this is sort of where like the real world is meeting like Google Analytics.
Yeah, exactly. So that's a very interesting case, which we believe can be like even commercialized in more similar use cases globally as well. And another use case here is the logistics we do in this kind of like, as you can see here, there are many trucks. So actually we try to track these trucks, like their staying time in these places to better improve the timetables and reducing waiting times of drivers. So basically what we do is that our cameras can detect like these kind of license plates and also matching with their staying time in these places and real-timely to update this information. So better help these owners of the place, better utilizing the like this space, better shifting the drivers, things like that. Yeah. So this is actually a very simple use case in logistics. You can actually think about a lot of like similar stuff, which you can do with kind of like the OCR plus some like management data, like captured from our devices. So it can be a lot of use cases. Yeah.
Very cool.
Nice.
Yeah. So we actually have more you can check out in our website if you're interested. So I think today we just give you some heads up, like to tell you the story of this platform and hardware already being in real life. It's not like a concept; it's already in real life. So we did a lot of successful things for the business or commercial. But why we are here today is that we also want to bring more new things people can play with. Even you're an individual, a developer who just have an idea. You can also work with our things starting from like now. Yeah. So I think I would like to move to like Amir and also later maybe the Glenn and Lakshantha. You can introduce more what we do for these community and developers. They can start immediately.
Thank you, Wei. Always a pleasure to hear you speak about Sony. So this was a great introduction to what we do and to the IMX500 and AITRIOS. I want to go a bit more technical in the second phase of this webinar. And I would like maybe start with a question to you guys, Glenn and Lakshantha. I was claiming back in YOLO Vision that Ultralytics YOLO is a model that by design is an edge-enabling model, at least the nano and small version of it. And I was wondering, how do you see it, guys, from your point of view, and what were your thoughts when developing these models?
Yeah, I can inject a bit of my thought process here. So a little known fact is that Ultralytics actually started doing particle physics. We spent a lot of time in laboratories next to nuclear reactors trying to catch electron antineutrinos. It was very difficult. And Ultralytics was the only startup in the program. And so I always had a commercial mindset. I always wanted to make the technology usable, take it out of the lab, put it in the real world. And unfortunately, we weren't able to do that. But fortunately, the work that we did there gave us an impetus to look at similar work that was happening in the computer vision space. And when I went over to computer vision, I saw a similar approach. So there's a lot of laboratory work, or more so academic work, which means that there's a lot of focus on making this chart better. And this is obviously the most famous performance chart that we have. It's the speed accuracy chart. The better you are, the closer you'll be to the top left of this, faster, more accurate, and so on. And you can do this on a benchmark data set, which is called COCO. And so there's a lot of research that happens, a lot of fundamental research at universities and PhD programs and in industry to improve these models in that direction. And it's very core, crucial research. But there's a second part of this, and this is really, in my mind, it's two dots. And the second dot is the real world usability. So computer vision, I think, is really a technology that lives at the edge. Everybody wants to have the models themselves on their devices, run it on their own hardware, and really own those inference results for a number of reasons. So the first is just cost. You'd rather not pay AWS every time you want to process an image. You'd rather just do that for free after you buy the hardware. So you invest in a GPU or a server, and then you can run it as long as you want for years and years, and you just pay the electricity if you're lucky and nothing breaks. Exactly. Second of all, and this isn't one that should be underestimated, is the privacy concerns. There's significant frameworks like GDPR, now the EU AI Act, and compliance concerns of large companies all around privacy. And so many companies have policies that restrict where data can go, and oftentimes images can't leave a premise. And so that means that the inference needs to be done on site. And the last one of course, is that images are large. So these aren't sentences that you send to an LLM. These are pretty large objects which take time, and that's latency, and that's also bandwidth. So as Wei was mentioning, if you can send less by processing the inference, then you save tremendously on bandwidth. But if you don't have to send anything anywhere, then you save much more. And so ultimately businesses look at this and they want the models right there. That means that the model typically has to run on an edge device, which initially was limited to a few small groups like NVIDIA GPUs. But now we see a proliferation of interest in the space, a lot of investment in the hardware space, and a lot of amazing edge devices like these Sony IMX cameras. And that means that the model has to export seamlessly, not lose any accuracy, and be compatible across a wide range of devices. Right. And so this is no longer really like academic research that's in the laboratory. It's kind of real world practice. And so a big part of what Ultralytics does behind the scenes that most people don't notice is that we're constantly testing export formats. So export and deployment are almost more important to us than data sets and training, because we want everybody to be able to run our models on all of the edge devices that we support. And we want to make sure that that's true day after day. So there's thousands of experiments that we run every week on all sorts of devices. We have a bit of an edge cloud, which is a strange phrase, but it simply means that we've plugged in edge devices to make sure that we can test those on an ongoing basis. So that also means that our models are performant, as you see in the chart, but even better, it means that they're simple to use and they're going to work when you actually try and use them somewhere. So if you have a 7-Eleven or a retail outlet and you want to plug that in on an array of hardware, the chances are that the Ultralytics models are going to work well for what you have. If they don't, we're here to listen to feature requests and bug reports. So a big part of computer vision, in my mind, is the real world that it's used in. It's not so much the laboratory that it's created in.
Definitely agree. Couldn't agree more. And this leads me to maybe to the next part, which is right. I agree that it has to be other than high quality, it has to be usable and easy to use. And eventually, we saw we had, as Wei mentioned, we had great success with the B2B world, with the commercial world. And enterprises loved the product, the IMX500, and got value. And we really felt the impact that we do by transforming to the edge. But we also quite felt the lack of impact, meaning why not enabling everyone to enjoy this intelligent sensor, this amazing technology? Eventually, why not enable edge AI to everyone? What about the community? How can we make edge AI simplified so that every person could use it? We wanted to enable vision AI without complexity, and for me, it's literally introduced a revolution in the vision technology. And the way we decided to go is by joining forces with the three industry leaders. Of course, the biggest provider of vision AI models, which is Ultralytics, the world leader in the sensor industry, and the biggest development kits provider, which is Raspberry Pi, a single board computers provider. For those of you who are not familiar with them, I will show you in a second what is a Raspberry Pi. But the idea was to streamline every aspect of edge AI from the development to deployment. So you can easily take a YOLO model from Ultralytics, and with several command lines, you can run your computer vision model on your Raspberry Pi. And eventually, we made it so that edge AI deployment on a Raspberry Pi takes minutes instead of days. This is how the camera looks, by the way.
It's so small.
It's almost.
Yeah, it's actually very tiny.
We need a banana for scale. Yeah.
Yeah.
We will see it in a second. We will also see how simple it is. By the way, we will do a real live demo. Raspberry Pi, for those of you who are not familiar with it, I have it right here with me. This is actually a mini computer, a Linux machine. You can see there's a USB cable. You connect it with an HDMI cable to your monitor, and you have a Linux machine. People do amazing stuff with it. The internet is full of it. And among other stuff that you could do with it, you can now also do Edge AI. As you can see here, a real Raspberry Pi device with an AI camera IMX500 connected. This is how it looks.
Amir, it looks like there's a second connector there of the same type. Could you plug two cameras into one Raspberry Pi?
So at the moment, it's a Raspberry Pi limitation that does not allow it.
Okay.
But hopefully sooner than later it will be supported.
Okay.
And I believe what's interesting about the connector is that the connector is not only supporting cameras; it's also supporting like displays, the DSA displays. So it's kind of like a multi, support for cameras and displays. Yeah.
Oh, interesting. Okay.
Yeah.
Great. So let's see the numbers. How well does YOLO operates on the IMX500? So currently in the Ultralytics package, you are already able to utilize the export for IMX with the YOLO V8 nano models, specifically object detection. In the upcoming weeks or so, we will add more tasks. And hopefully sooner than later, YOLO 11 will also be available within the Ultralytics export.
That's right. Yeah,
Sorry?
we're working on, that's right, Amir. So we're working on export support for YOLO 11 models also.
Right. This is something that we are keen to have in production. We already, in our labs, we already have the YOLO 11. And as you can see, numbers are really close from both sides to the floating point model. And the weird thing is that although we would expect faster inference latency on the YOLO 11, numbers are pretty much the same.
These are quite similar.
Yeah, they are similar just because of different implementation, which happens to be at this latency. And specifically, I would say that the inference latency here speaks specifically on the NPU part, on not end-to-end from sensor to the application. So this is the time that it takes to the sensor to process the AI.
Okay. So that's real time then. So you can get 30 frames per second from this thing.
So this is the thing that mainly because of things that are not related to the inference latency.
Okay.
Sometimes it gets lower than that, but eventually it's a one-chip solution, so you don't need any additional AI processing unit or a round trip to the server. Everything happens on the sensor. It is low power and optimized processing, so everything happens on the chip and requires less bandwidth, as you mentioned, and less power. It's cost effective, of course, and addresses privacy concerns because you are able to keep the frames on the sensors and provide only the metadata, or you can provide both. Everything is processed on the edge. As you mentioned, sometimes I love to call it extreme edge.
That sounds about right, yeah. And I think, Amir, on a side note, I just want to mention that we showcased this demo at the Maker Faire Shenzhen last year in November. So we had a booth in Shenzhen at Maker Faire. And actually, I placed the demo, and the demo is actually running from morning, from 8 in the morning until late evening, 6, 7, constantly for 2 days straight. So it was pretty interesting to see the camera running, with no issues at all. Yeah. For 2 days. Yeah.
Did the Raspberry Pi machine got hot?
No, it was
Yeah, this
doing
is
good
what I
because
was.
because
Yeah.
I'm using like a heat sink with the Raspberry Pi. So the Raspberry Pi has an official active cooler with a fan. So I have connected that one on the Raspberry Pi in order to keep the temperatures down on the Raspberry Pi. So
Cool.
the entire system was kind of not generating a lot of heat, even though I was running for 2 days straight, which was pretty interesting. I would say.
Actually,
Yeah.
that's right. It's by design, by the way, because
Huh.
as I mentioned, we started off with the commercial world, and one of the requirements from the industries was to have I wouldn't say rigid, but a robust enough device that will run 24/7 and won't be ruined from every single bump. So it's quite, I would say, by design. Yeah.
Mhm.
Hey, this is interesting. I was about to ask a question on this because usually I'm used to edge devices throttling after a while, overheating, and so on. But like Lakshantha, you're saying this thing was running almost 2 days and
Yeah.
it was fine. Yeah.
Yeah, because as I mentioned, like it's using the Raspberry Pi cooler. So okay, I can't show you right now.
But the camera,
Wait, so this
the
is
camera,
the
though,
Raspberry
the
Pi.
processing.
You see?
Okay, but hold on. But the camera is doing the processing, right? When there's no active
Yeah.
cooling on the camera.
Yeah. So this is the camera.
Okay. Oh yeah, that's really cool.
Yeah. And
all right, so the camera is pretty thermally efficient then. It doesn't need any active cooling. You can run continuously.
right.
No,
Right.
the camera doesn't get heated at all. If
Yeah.
at all, it will be the Raspberry Pi itself. But as you can
Wow.
see, it
Okay.
doesn't.
Yeah.
Okay.
Cool. Second, sharing the screen again.
Oh, by the way, guys, for all the listeners out there, make sure you drop any questions here in the YouTube chat, and we're gonna get to those a little later. That's the funnest part for me, actually.
Cool. So I wanted to present some cool projects that was made by the industry, by the community. Sorry. So 1 second. Here you can see some gear inspection application that counts how many people are with or without the relevant gear, or queue management that we can see right here, even traffic management. I got a video of a parking lot management. There you can see how many free spaces.
These are the free spaces you're always looking for, but you can never find.
For
those are the free spaces you can never find when you need them.
Yeah.
This is a training assistant. As you can see, it counts how many repetitions. But
this is cool. Yeah, this is similar to what Mohammed's been doing here, making a lot of workout videos. He should be in great shape by now, by the way, depending on all the videos he's made.
Too many testing, sir.
Yeah.
Actually, you can simply go to YouTube and write Raspberry Pi AI camera. You will see so many of those projects people did by themselves.
Oh yeah, super cool.
Yeah, same for LinkedIn. I can see I searched for Raspberry Pi AI camera. So this dude made this cool robot that tracks them. So yeah, a lot of great stuff that you can find online. And
guys, let me ask another stupid question here. If I want to place the camera further from the Raspberry Pi than the connector allows, because it seems like it's maybe a 10-centimeter connector, is there an extender or a different version with a longer cable?
So my answer is as far as I know, there is no such option. Okay. But as you know, the Raspberry Pi Foundation and community, they will find a solution for such a use case.
All right.
To make it different. Lakshantha, do you know otherwise?
Yeah, I think Glenn, when it comes to the cable, the official cable from Raspberry Pi itself, the longest cable that they offer is like 500 millimeters. Yeah, 50 centimeters. Yeah, basically.
Oh, okay.
That's the longest one officially offered by Raspberry Pi. Yeah. So the orange color cable that you saw before,
Yeah,
So
yeah,
that
that's what I
is
was
the
thinking.
one. I think when you buy the Raspberry Pi camera, like by default, it comes with like a 200 millimeter cable. That is the default one. But as an additional, like, purchase, you can get the 500, which is the longest. Yeah.
Oh,
So that
okay,
is what
okay.
I've seen. Yeah.
Yeah, that might be more applicable for, I think, robotics applications. So you can put cameras on actuators and you leave the processing, for example, in another spot. Okay.
Cool. So I urge you to go and look for Raspberry Pi AI camera projects with and see how you can reproduce or do your own projects with YOLO exported to the IMX500. And I also urge you to upload your project to the web, to GitHub, so make the community to be able to enjoy the same solutions as you developed. Yeah, so I think it's time for Lakshantha.
All right, so this wouldn't be a live session if it didn't involve a live demo. So these go right about half of the time. So let's see what you got today, Lakshantha.
Okay. Let's hope it goes well. Live demos are always not going as to plan, but let's see. Yeah. So I think before moving into the demo, I will quickly explain how we actually integrate the IMX500 into our Ultralytics package. So actually, if you go to docs.ultralytics.com and inside the integrations, so these are all the different integrations we have done for different export formats. And IMX500, Sony IMX500 is one of them. So if you go to Sony IMX500, this is the official documentation that we have at Ultralytics documentation. So you can simply run this command on your PC. So YOLO export model YOLO-V8N. So this is actually the pre-trained model on the COCO dataset, and then you can specify the format as IMX. And this argument, you need to pass this argument because when you are doing an export to IMX500, it's actually doing INT8 calibration at the export process. So you need to define the dataset for the calibration. So this argument is not really necessary to pass because by default we are using COCO 8 dataset in the export. But if you want to use another, like a larger dataset, such as the full COCO dataset, you can directly pass COCO YAML in this one. And also not just the pre-trained models. If you want to bring your own model with your custom trained custom dataset, you can simply go to if you go to modes under training. So under training, you will find how to train your custom or your own model with your own custom data set as well, and you can bring that to this export. And in that process, you need to define your data set here for the calibration. So that is the export.
I will say this data is a representative data set. It doesn't have to be the whole data set, but it's better to be as many images coming from your data set instead of COCO, if it's your data set.
Yeah, definitely.
That's a good point.
Definitely.
Yeah, because the domain could be pretty different.
Yeah. So to give you a quick idea about the export process, so actually what's happening under the hood is we are bringing in the PyTorch model, the floating point model, and then we are going the model is being gone through the model compression toolkit and the converter, which is already integrated into the Ultralytics package. That is what we did with Sony together in order to make this happen, so that we want to make the export process as seamless as possible for the end user. So what the end user will get is a model, a file, which need to copy into the Raspberry Pi, and then you need to have, there's another small step which needs to be done on the Raspberry Pi, which is packaging the model in order for the model to be compatible to run on the Raspberry Pi. So that is the step. So you guys, community, you guys can go to this documentation and follow all these steps in order to get this Raspberry Pi supported model through going through these tools. And then once you get the model, so I already have gone through all these steps and I have actually got a model. So I will switch to my other screen. So this is actually, so I have now, I'm inside the Raspberry Pi right now. So this is the terminal of the Raspberry Pi. And actually we are running this demo inside the Pi Camera 2 applications, right? So because Pi Camera 2 is officially offered by Raspberry Pi, and it packages different applications, and the IMX500 object detection application is one of them, which is officially included inside the Pi Camera 2
Oh, cool.
application. So it's under the examples IMX500. So I will quickly run this command. So this will actually, you see, this is the model that I got after going through the conversion toolkits inside the Raspberry Pi. This .rpk file format.
So the
so
RPK is when you do export, you get this RPK file, and the command, this command you just pasted, is the last command from the documentation of Ultralytics.
That's right. So this is the command. This is the exact command that I'm running right now. This is the command. And so the reason I'm using this display 0 is because right now I have connected the Raspberry Pi. Okay, it's kind of like a setup here. So I have connected the Raspberry Pi through a HDMI adapter, HDMI what do you call it? Video capture card, right? So basically, the HDMI signals from the Raspberry Pi is being converted into USB, and it's being output from the PC, just like that. So this is OBS. So this is the output from the Raspberry Pi on the right hand side. So I will quickly run this one. So now it's actually
what Lakshantha just said is only matters for demo purposes. The display 0.
Yeah, it only matters for demo purposes.
It sounds like what you were talking about before with the other connector to the display, right?
No, it's actually it's called a HDMI capture card, which
okay, so it's not okay, never mind.
Yeah, which you can actually, because normally if you want to have the Raspberry Pi with a display, you need to connect the Raspberry Pi HDMI to another display, right? To actually get the display out of the Raspberry Pi. So, but here I have directly connected the Raspberry Pi to my computer, the HDMI of Raspberry Pi to the computer, and the computer is capturing the HDMI signals from the Raspberry Pi through that HDMI capture card that I am using. It's kind of like a intermediate connector between HDMI and USB. Yeah. So that's why I have passed this display 0 command here, just for this demo purpose, in order for us to see everything in one screen. Yeah. So now the model is building. Yeah, model is loaded right now.
We can see you.
There's Lakshantha. Lakshantha, where'd you get that sweatshirt from?
Oh yeah, it's a cool sweatshirt.
Did you buy that on the Raspberry Pi store?
I also have it.
Oh, that's right. You got the white one. Actually, well, I've got the T-shirt version. We'll have to send me one. Next time we get out there.
So this is actually the.
I need one for this group.
Stay warm in the winter. Yeah.
This is the Coco, the pre-trained model with Coco dataset, and let's look at some other screens as well. So this is my setup. So we have the mouse, the keyboard. Sorry.
All right, that's picking the mouse up, the screens, the keyboard. It looks like it's working.
Yeah. So the keyboard, mouse, and the 2 screens are being detected, right? Yeah.
Yeah. Nice.
So
okay.
That's basically the demo. Yeah. It's nice that it all worked out. Yeah. Okay.
You got lucky this time, Lakshantha.
Lucky this time.
Yeah. Okay, guys. Let's see here. Oh yeah. Oh, keyboard interrupt. Okay, that's good. That's an okay.
Yeah, just a comment. That's so now we only have this object detection. Maybe we can do with this documentation, but actually we have to be supported all the tasks very soon, as we mentioned from the beginning. So you can do more things with this device, with YOLO, not only for object detection, many other things.
Agree.
Yeah, absolutely. We actually have 25 different open source models for YOLO 11. So there's 5 different tasks for 5 different sizes each. So there's the 5 object detection models, which are really the original YOLO task. And they still comprise, I think, maybe 75 to 80% of the use cases out there. But there's additionally instance segmentation, pose estimation, image classification, and oriented bounding boxes. And maybe new ones in the future. So then we might have something special this year. So, okay, guys, we are running short on time here. So we've got 10 minutes left.
We'll have to wait.
It looks like we've got, yeah.
Sorry.
So what'd you say, Amir?
I said we'll have to wait for the YOLO Vision for the next thing.
September, that's right, actually. We're doing it in London this year, so that should be pretty exciting. Right. It's the first time we've stepped out of Madrid. So
nice.
Wow, that's cool.
Yeah, okay. It should be really fun.
So let's get to the questions. Before we get to the questions, I just want to say that in terms of resources, we've blown the web with examples, tutorials, videos, use cases, everything for you to be able to overcome any difficulty and make the deployment on the IMX500 easy. And of course, above all, there's the power of community. We can already see people are helping each other within the community or just online. So we have the Ultralytics documentation that we just saw. We have the Sony developer website that has a lot of resources as well, and the Raspberry Pi AI camera forum. Maybe I will do a short walk around just to.
All right, I'm looking through the questions here.
Yeah, I think meanwhile we can cover
there's
the
a few interesting ones. Yeah, let me grab one of these. We'll start working our way through these.
Yeah.
So most recently. Oh, okay. Oh, go ahead, Amir. You pulled it up.
Okay, so we have the Raspberry Pi AI camera forum. You can see people are posting their issues and projects. We have the developer website that has all the resources for you to be able to run any model on your device. Specifically, if you go here to the tutorials, you will quickly find your way back to the Ultralytics IMX500 export. That's about it. Also, Raspberry Pi has their own documentation and resources. And this is where you can buy it through Raspberry Pi. We'll go back to the presentation.
All right. Let's see. Yeah, so guys, as Amir saying, there's a lot of resources available here, both on the Sony side, also on the Ultralytics side. We try and do our best with the documentation, but if there's anything missing, definitely let us know. We're always there on GitHub in the issues and the discussions. And of course, like, how do we get these, Amir? How do we actually buy one? I don't see the questions, but I think that's probably an important question.
So exactly the slide that I'm sharing, simply scan this QR code to get to the AITRIOS developer website where you can see all the resources and where you can buy, or simply go to Raspberry Pi and search for the AI camera under the Raspberry Pi shop.
Resellers, yeah, I think they have like global, very big distribution channels. So basically, you can buy it from anywhere.
Right. When you go to the Raspberry Pi store and you ask to buy an AI camera, you click it, you will see, according to where you're at, which resellers are good for you to get your hands on the phone.
Actually, this is a perfect answer here to Youssef's question. So he says he's from Morocco. He says he can't get his hands on these edge devices easily. Could you facilitate shipping for us? We're patient. We can accept slow shipping options.
So
I was a little surprised in Morocco.
Where is he? Okay, Morocco.
So I think there's resellers for almost every country. So I was a little surprised myself, to learn that Raspberry Pi sells Raspberry Pis, but they also work with many other suppliers and many other resellers. So there should be one for your region. But I think as Amir was showing, if you go to the Raspberry Pi page and you put in your location, I think they'll probably present different local options for you.
Yeah, they will. They have very like smart kind of like, yeah.
Okay. All right, let's see here. Okay, so Let's see. I've got a good comment. I guess more of a comment than a question from DB. He says IMX500 must solve the manual focus. We are operational edge AI with Ultralytics YOLO YOLOv8 models. We've got 12 Raspberry Pi 5s deployed with IMX500 cameras. He says in the edge, it's difficult to spend time manually focusing each camera. So maybe
that's a good
good
point.
piece of feedback to take there to the engineering team.
Exactly. I will take it back to the engineering team. It's not something that I'm familiar with that is an issue. So I would love to hear more about this thing to maybe try and resolve. Maybe try to raise this issue under the Raspberry Pi AI camera forum, the Raspberry Pi forum. We will put the link right here, and we will be able to support you.
Yeah, this may be related to close-up imagery, because I think a lot of cameras may focus to infinity, but for a lot of manufacturing applications, perhaps the sensors are closer for smaller objects. So, but not sure. But yeah, it's a good point there.
Right.
Let's see here. Oh, he's got a few more details. This is interesting. He says detection of 1 centimeter cubed objects on runways and taxiways of airports. Solution is an edge device for AI and a sensor that has capacity to serve images at 30 to 60 FPS at 35 meters distance. Okay. So in this case, they're pretty far away, but they're small objects.
So I think it's measured not by how many centimeters, rather than but by how big, like how many pixels is the object. So
yeah, and from experience, you need to be in a place where you have at least 2 to 3 pixels for an object, and ideally more. 2 to 3 is sort of like the threshold when it starts to become possible to detect objects. But again, that leaves it really difficult to separate from the background noise. So in that case, I think either a narrower field of view for more of a zoom or a higher resolution sensor would be the best way to go. But it's a difficult problem.
12.5 megapixel. So it's in terms of resolution, it's very high resolution. I assume
12 megapixels. That is a lot. So that's like 3,000 by 4,000.
Yeah.
Yeah. Okay. Okay. So the resolution is definitely there. Well, okay. So the sensor is collecting 12 megapixels.
Yeah. Right.
The inference, though, yeah. So the inference is a little lower. It's probably at 640 by default. Yeah.
Exactly. 40.
Yeah.
Interesting. So I suppose like a typical solution there would be to run less frames per second with a higher resolution, and that would give you more of a chance to see those smaller objects.
Right.
By the way, we also have a related question about field of view for the camera. So I'm assuming it's probably in a data sheet, right?
I
like
think
where can we get all this info?
we already copy paste that our sensor kind of data sheet to the comments. Maybe they can check like everything. It's around like the like the FOV, the diagnose like FOV is like around 80 degrees. Maybe you can check out like more details of the spec sheet.
Okay. And then Steve Gulick here says, can it be interfaced to an ESP32 or similar MCU? So we've gotten the Raspberry Pi demo, which is really cool. But can it be plugged into other boards?
Yeah, we actually have other devices ready to purchase, already being like connected with other options. So for people who like to buy like a already ready to made, ready to use camera instead of like this Pi camera for like more playful stuff, you actually can also check out our the AITRIOS website. We already have like this like smart device you can buy directly with you mentioned like these other MCUs, other options we have.
Okay. Oh, and Steve came back here. So Mr. Gulick is asking, how does the IMX500 compare to the IMX462 with respect to low light in the near infrared? This is quite a technical question, but it looks like the 462 would be before the generation where we're processing on the device.
Right. So I think it's not quite an apple to apple to compare between the two. In terms of specifically that specific IMX, I'm not familiar with, I would go and look for specifications and under this Sony developer Sony website. The link is just being shared here in the chat, and you can go and look for different sensors. But by the way, this is the sensor with the AI accelerator without the sensor. This is how it would look.
Oh wow!
If it was standalone.
Okay. All right, so Jay Suresh has an interesting question. He says, is Edge AI competitively scalable as relying on traditional cloud computing providers?
Again?
So he says, is Edge AI a scalable strategy when compared to traditional cloud computing providers like AWS and Azure? So I would say the cloud providers are mature, they're reliable, but that comes with a price tag. And so the price tag is also scalable with the number of cameras you deploy if you're running them in the cloud. And so this is fine, I'd say, for a small scale application. But if you're like 7-Eleven, for example, and you may be scaling to thousands of cameras, then your inference bill will be quite high on the large clouds, or even smaller clouds, which may be more competitively priced, but perhaps less reliable. So I would say for volume applications, it's definitely a preferred method. There's, I think, a higher upfront non-recurring engineering effort that you need to put in. But once that's done, I would say that you can continue to scale those deployments, and then the economics become more and more favorable over time.
And I want to add something there. That is, I think when it comes to security, it's like a major concern these days. And I think people do not want to send their data back to the cloud, so they want to keep everything at the edge.
Yeah.
So I think that is also one of the big things about running all these models at the absolute edge, I would say. Yeah.
Yeah, and we see that in LLMs too, by the way. But yeah.
Right. The thing about AITRIOS is that it enables edge AI in a scalable manner, because part of it is AI development, but part of AITRIOS is device management and the ability to, for example, deploy a model on 1,000 devices across the country with a click of a button through the AITRIOS management system. So the whole idea of AITRIOS is to make edge AI in a scalable way.
And we've got two interesting questions from the horse, as his username is. He says, does this need a Raspberry Pi 5? So 5 is one of the newer generations that came out recently. Pi 4s are not as strong on the compute side. Can they run this?
Yes. So
I think I asked the same question from Amir yesterday, right?
Right.
Yeah. Yeah.
It's a good question. I'm interested in the answer also.
So yeah, I have this Raspberry Pi 4. It runs on Raspberry Pi 4, and it also runs on the Raspberry Pi Zero. Of course, for better performance, you better get the 5. But it depends on the use case. There are use cases where the Raspberry Pi Zero performance is just fine. If you need less.
Okay.
Yes.
All right, and then the last one here is from Matthew B, who's had some really nice things to say about us. Thank you. He says, if we integrate IMX500 onto a drone, what distance may we expect to capture objects? So
we actually haven't tried to integrate into a drone. I want to know as well. Maybe Amir, have you done any experiment?
I did see. Let me look for it. I saw somewhere in YouTube a user that did that.
This is all like we have a drone data set. It's called VizDrone, and typically the objects there at 640, maybe 5 to 10 pixels across. So I would say yes, but like most answers, it really depends on where the drone is, the distance to the objects, the size of the object. So I would say for typical VizDrone applications, yes. So that would make for some cool visuals. And let's see. I'm going to pick one last question here. Jay Suresh, he's got a really interesting question, which again doesn't have, I think, a perfect answer. But he says, is metadata inference enough to provide a large-scale retailer insights into consumer behavior, or are additional considerations needed? So this is a great question, and I think it really depends on the model. if the model is capable of extracting
Yeah.
sufficient metadata of sufficiently high quality, then metadata only may suffice.
Right.
Whether the models that we have today are at that level, that's another question. But I think we're gonna get there, if not today, at some point soon. So
right.
Okay, all right, guys. We went over a little bit, but there were just so many questions here. I wanted to get through a few of these. So thank you, everybody, for joining us. Thank you to the community, not just for tuning in today, but for all the amazing contributions you've made over the last few years to the open source space. You know, we wouldn't be here and be able to do this without you. So, and also great big thanks here to the Sony team. Thank you for joining us, explaining how these cameras work and giving everybody a demo here, Lakshantha. So thank you guys, and looking forward to the next YOLO Ultralytics Live session.
Thank you so much. Looking forward to
Thank
seeing
you.
you.
Thank you, guys.
Thank you, everyone. Bye.
Thank you, guys. Bye.
Bye. Bye.
Okay.